Okay, welcome back. In this video, we're going to go over how to interpret a mass spectrum after you've inserted a mystery element into a mass spectrometer. This right here is a classic example of a readout that you will get after you've inserted a sample into a mass spectrometer. And we can use this readout to help identify the mystery element, okay? You notice here that there are 5 red lines. Each one of those lines are a peak, and they correspond to the relative abundance of the isotope as well as its mass number, okay? So each one of these peaks is an isotope of whatever this mystery element is. Down here at the bottom, you'll notice that along the x-axis, that corresponds to the mass number or the atomic mass of each one of those isotopes. So this first peak here represents an isotope of a mass of 72. This second peak represents a mass of 70. I'm sorry, this is 70. This second peak represents a mass of 72. This third peak, 73, 74, 76, and so on. So every place there is a red line is where an isotope has come up, and that and the bottom number there corresponds to its weight. Along the y-axis here is the percent abundance, so how much of that isotope is in this sample, okay? Now this is the tricky part, because we don't have the scales right here to help us count where these red lines are stopping, so we're going to have to make some estimates as to what the percent abundance for each one of these isotopes is, and then we'll use that to help calculate the atomic mass and then eventually identify what this element is. So for this first peak, it's pretty much right on the line of 20. So I'm going to say that the relative abundance for this isotope here is 20%. So I draw this little line here, that's called an extrapolation, and it helps me measure it up to where the 20% line is. Let me show that a little bit better. Okay. Alright, for this second peak, it's not quite at 30. It's a little bit lower than 30. So I'm going to estimate maybe about 28%. Okay, that's a pretty good guess. For this low peak right here at 73, well, it's not quite at 10. That's a little lower than that. Let's go ahead and estimate maybe 8%. So this isotope right here has an 8% abundance. This peak is the largest peak, and it is not quite at 40, it's a little lower than that, right about there. And this one's going to be a little hard to interpret. If 35 is about there, then this must be maybe 36. Okay, it must be 36. And for this final peak, well, this one's pretty much in line with that peak there, so I'm going to say this one is 8% as well. No matter what your guesses are, ladies and gents, they need to be reasonable, meaning they need to be within the range that they're in. For instance, it wouldn't be a good idea to interpret this as 11. And they have to add up to 100%. And in fact, if you take out your calculator and add up each one of these numbers, the 20, the 28, the 36, and the 2 8s, those are going to come together to be 100%. Remember, 100% abundance. The percent abundance has to come out to 100% total. All right, we are going to use this data to now calculate the average atomic mass of this mystery element. And then once we know what that is, we can go back and compare it to the periodic table and identify this mystery element. So how do you calculate the average atomic mass? Well, what you do is you're going to take the mass of each one of these isotopes, and there are 5 total, and you're going to multiply it by its percent abundance. So I'm going to take the first mass, multiply it by its percent abundance. I'm going to add that to the second mass, which would be this one, multiply it by its percent abundance, then do the third mass, add it to the third mass, multiply it by its percent abundance, let me make that look neater, add it to the fourth mass, multiplied by its percent abundance, and then the fifth one, which I've ran out of room, but you would include it in your calculation as well. All right, so what's that going to look like? Well, the first mass is 70, And then I'm going to multiply it by its percent abundance, but be careful. You have to use the decimal form of the percent. The percent abundance for that first mass is 20%. The decimal form means you move the decimal place 2 places over, so 20% is actually 0.20. You have to convert it to the decimal form. Alright, we're going to add that to the second mass, which is 72. And it has a 28% abundance, which in decimal form is 0.28. Add that to the third mass, which is 73. Multiply it by 8%, which is in decimal form 0.08. Add that to the fourth mass, which is 74. Multiply by its percent abundance, which is 36, in decimal form 0.36. And then finally add it to the fifth and final mass, which is 76, multiplied by its percent abundance, 0.08%. Okay? Now it's just a matter of plugging it into the calculator, okay? What I would do first is multiply each one of these things together, the mass times its percent abundance, and then I would add everything together at the end. Now, in the sake of time, when I do this, I come up with 72.2 as my average atomic mass. So what do I do now? How do I identify this mystery element? Well, what we're going to need to do is we're going to need to go to the periodic table and then find the average atomic mass that is either exactly 72.72 or very close to it. So as luck would have it, I do have a periodic table right here. So I've already got it highlighted for you, but if we come down here and look at germanium, we see that germanium has a average atomic mass of 72.59. That's pretty close, but just to be on the safe side, let's look at the next one over. Arsenic is 74.92. That's too far away. It's not close enough to 72.72. However, 72.59 is close enough, so this mystery element is in fact germanium. Alright, ladies and gents, and that's how you interpret a mass spectrum. There will be other questions like this in this slide, and then during our synchronous time, I will go over ways to figure out percent abundance when you already know the atomic mass and so forth and so on. So we'll do different variations of this type of question. But this is a very common thing that you could see on the AP exam, where they give you a readout and then you have to interpret what the mystery element is. Okay, so go ahead and work through the next slide, which is another example problem with a completely different mass spectrum, and see if you can identify that mystery element.